The first lesson that we'll be covering in algebra is basically a review of certain concepts that you should have learned in the previous years. So we're going to start out with integers and fractions. Here are a list of words that represent both positive and negative numbers. In case you were given a story problem, you would understand what kind of number was being represented. If you were to be asked to plot numbers on a number line, you would just use a closed circle on the specific number. So the first one that we have to plot is -3. I'm going to go to -3 and just put in a closed circle. So I'm done with -3. Next we have -5, +4, +2, and then this one is kind of hard to see, but it should be 1/2. So I'm going to go between 0 and 1 and make a mark. If you were to ever forget the rules for adding integers, you'd want to come back to this slide because it gives you specifics. So we're going to start with adding integers with the same sign, meaning a positive number plus a positive number, or a negative number plus a negative number. And the rule is listed right down below, and it says add and keep the same sign. So by the end, we should be able to answer the following questions here. Looking at a number line, you can see how adding integers with the same sign works. So if we had a +3 plus a +7, we would start at 0, we'd move 3, +3, and then we'd move +7, and we would end up at 10. If we were using negatives, we'd go back 2 for -2, and back 6 more, and we'd end up at -8. Another way to think about this is if you were to think about it in terms of money. So if I lost $7, that'd be -7, and then I lost 9 more, I would have lost $16 overall. If I were to lose $4 and then lose 2 more dollars, I should have lost 6 overall. Now if I'm talking about winning $5 plus winning $3 means I won $8 overall. So here were the questions at the very beginning in which we should be able to answer. And so what I want each of you to do is take a minute and try to answer the following questions. When we're doing 16 plus 25, this is a basic that we should have known from previous years. We want to carry, we end up with 41. The next one we have two negative numbers, which doesn't change anything. We just simply add the 23 and the 8. We ignore the negatives for now. We end up with 31, and that would be a negative. Now, when we have fractions, if we already have a common denominator like we do, then all we have to do is follow the operation in the middle. So, just like before, I'm going to ignore the negatives. I've got 1/5 plus 2/5, which is going to give me 3/5. And since they're both negative, I'm going to end up with negative 3/5. Now the last one is a tricky one. It's bringing back some things that you've done in previous years. In order to add these two, the first thing that we need to get is a common denominator. The common denominator between 3 and 4 is 12. So I'm going to rewrite this as something over 12 plus something over 12 equaling something over 12. To get from 3 to 12, we multiply by 4. So I'm going to also multiply by 4 on the top, so we get 4 twelfths. To get to 12, we multiply by 3, so I'm going to put 3 twelfths, and 4 twelfths plus 3 twelfths gives us 7 twelfths, and I can write in my answer. Coming back to this slide that had our rules for adding integers, you'll notice at the bottom it explains how to add integers with different signs, meaning a positive number plus a negative number, or a negative number plus a positive number. The rule is listed below that we would need to subtract the two numbers and keep the sign of the bigger number. By the time we're done, you should be able to answer the following questions. So if we were to take a look at the number line, we would notice we have positive 2 plus a negative 5. So starting at 0, if we went positive 2, we'd end up right here. But then we have to go plus a negative 5, so we're going back 5. We end up at negative 3. With example 2, again, always starting at 0, the negative 2 takes us back to negative 2, plus a positive 6 takes us to positive 4. Another way to think of it is if we lost $7 but then gained $10, we would end up with gaining $3 overall. If we won $4 and then lost $6, we would have lost $2 overall. If we lost 8 and then won 3, we would have only lost $5 after all. Here are some practice problems that you would like to consider. And here, we always want to take the bigger number minus the smaller number. So I'm going to look at it like this. We've got 25, and we're going to subtract 16. We are left with 9. And we have to decide if it's going to be positive or negative. Since the bigger number, 25 is bigger than 16, is negative, then our answer would be negative. Here we've got 23 plus negative 8, so we're going to do 23 minus 8. We end up with 15, and since the bigger number is positive, we get a positive answer. Now we're to our fractions, and so we're going to take the bigger one, 2/5, subtract the smaller one, 1/5, and we're left with 1/5. And since the bigger number is positive, our answer is positive. Down here, we have to get a common denominator. So again, just like the last time, our common denominator between 3 and 4 is 12. So we're going to rewrite this as multiply by 4. 4/12 plus negative 3/12. And we have to decide what that's going to be. So we're going to do 4/12 minus 3/12 and get 1/12. And since the bigger one is positive, our answer is going to be a positive 1/12. Here are some more practice problems that I'd like you to do on your own. These are the answers that you should have come up with. We have -2, -31, -5/5 or -1, and 5/12. The additive inverse property just says that a sum of a number and its opposite is always going to be 0. So if you have 4 plus -4, it's going to be 0. If we had 5 plus -5, we'd have 0. Any number and its opposite is going to give you 0. Couple word problems that we want to set up. The first one says the temperature at 6 a.m. was -6 degrees Fahrenheit. The temperature rose 12 degrees by noon and another 7 degrees by 5. What was the temperature at 5 p.m.? So we started at -6 degrees. If we rose 12 degrees, we went up positive 12 degrees, and then we rose another 7 degrees by 5. So we'd have -6 plus 12 plus 7 in order to come up with our answer. -6 plus 12 is going to give us a positive 6, and 6 plus 7 is going to give us 13. So we have 13 degrees Fahrenheit. The second one says Mary spent $15 on a sweater. If she's spending money, she's taking it away, and another $8 on a shirt. Using integers, write an expression that could be used to determine how much money Mary spent, then determine how much she spent. So she spent 15, and then she spent another 8. So if we added the two together, we'd get a negative 23, which means she spent $23. Moving down to question 3, it says, a meteorologist reported that the temperature at 9 o'clock in the morning was negative 25 degrees Celsius. The temperature rose 11 degrees in the next 5 hours. What was the temperature at 2 o'clock in the afternoon? So what we're going to have to do is we're going to take the negative 25 degrees Celsius and we're going to add the 11 degrees and see what we come up with. I'm going to do 25 minus 11. We get 14, and since the bigger number is negative, we're going to end up with negative 14 degrees Celsius. The next one, it says, Joey made $25 last week walking his neighbor's dog. Unfortunately, he owes his sister $38. Write an expression using integers to represent this situation. After paying his sister, does Joey have any money left, or does he still owe his sister? Explain. So if he made $25, that's going to be a positive $25, plus he owes his sister 38. If he's owing somebody money, it's going to be a negative 38. So we're going to see where he ends up. Over here, we'll do the 38 minus the 25, and we will come up with $13. However, since the bigger number is negative, it's going to be a negative 13. So to answer the question, if he still has negative $13, that means he still owes $13 to his sister. So now we've finished adding integers, but we're not done with adding integers because you'll find that subtracting integers ends up bringing you back to addition. So the rule for subtracting integers that you probably learned in the past was either keep it, change it, flip it, or you were told to add the opposite. So like before, we should be able to answer these questions before we finish this lesson. The one thing that I'd get in the habit of doing is rewriting your subtraction problems just so that you're understanding exactly what we're doing. So if we want to add the opposite, or keep it, change it, flip it, we keep the first one, we change the subtraction sign to addition, so I'm going to put my plus in there, and then the opposite of negative 6 is positive 6, so I'm going to put that right here. I'm going to go through and just practice keep it, change it, flip it for all of this, and then we'll come up with our answers. So keep the first one, change subtraction to addition, and flip the second one. So positive 4 becomes negative 4. Keep the first one, change the subtraction to addition, and flip it from positive 11 to negative 11. Keep the 6, change it to addition, and the opposite of negative 2 is positive 2. Keep the negative 8, change it to addition, and flip the second one, and we get a positive 14. So now we can go through and follow our rules for addition. Negative 5 plus positive 6 is going to give us a positive 1, because we take the bigger minus the smaller, and since it's a positive, we get a positive. They're the same signs, negative 8 plus negative 4. 8 plus 4 gives me 12, and we keep the sign. Negative 9 plus negative 11, they're the same sign, so we're going to add them. And since they're negative, it's going to stay negative. 6 plus 2, that's an easy one. And then we have negative 8 plus 14, so if we did 14 minus 8, we'll get 6. The bigger number is positive, so it's going to be positive. Okay, we're going to practice again, keep it, change it, flip it. If you want to just do it on the original problem over here, you can. I'm going to do it in both places so you can see. So we keep the 5, we change it to addition, And then the opposite of negative 6 would be positive 6. Keep the 8, change subtraction to addition, and flip the second, we get negative 4. Keep the first one, change it to addition, and the opposite of 11 is negative 11. Keep the first one, change it to addition, and the opposite here is a positive 2. Keep it, change to addition, and flip it to a 14. 5 plus 6, that's easy. 11. 8, take the bigger minus the smaller. 8 minus 4 gives us 4. Bigger number is positive, so it's positive. Take 11 minus 9. We get 2, and since the bigger number is negative, it's negative. We do 6 minus 2, which gives us 4. Since the bigger number is negative, it's negative. And then we've got 8 plus 14. It's going to give us 22. That takes us back to elementary school there. The next set of problems that we have is just continuing on with those integers, and we are going to practice now with our fractions. So we're going to do the same thing. Keep the 1 6, keep the first one, change it to addition, and the opposite of negative 5 6 is positive 5 6. Keep the first one, negative 1 6, change it to addition, and then take the opposite, negative 5 6. The next one, keep the 5 6, change it to addition. The opposite of negative 2/3 is positive 2/3. Okay, we want to keep the 1/3, change it to addition, and the opposite of negative 1/4 is positive 1/4. Keep the negative 1/3, change it to addition. The opposite of negative 1/4 is positive 1/4. So then we want to go through and figure out our answer. 1 6 plus 5 6, they already have a common denominator, so that's going to give us 6 6 or 1. We have a common denominator on the next one, negative 1 6 plus negative 5 6. They're the same sign, so we're going to add them. It's going to give us negative 6 6 or negative 1. Here we have to find a common denominator. The common denominator between 6 and 3 is going to be 6. So I'm going to just change this one here. I had to multiply by 2 to get to 6, so I'm going to multiply by 2. So I have 5 6 plus 4 6. That is going to give me 9 6 for my answer, or 1 full and 3 6, or 1 1/2. You could also put 1.5 if you wanted. Any of those answers would be acceptable. So the next one, we have to find our common denominator, which is going to be 12. I'm going to rewrite it as something over 12 plus something over 12 equaling something over 12. We multiplied by 4, we multiplied by 4, or by 3. So we have 4 12s plus 3 12s, giving us 7 12s. Here, our common denominator is going to be 12. So we've got something over 12 plus something over 12 equaling something over 12. We multiply by 4. Negative 1 times 4 is negative 4. We had to multiply by 3. We get 3. We have to take our numerators and subtract. 4 minus 3 gives us 1, and since the bigger number is negative, it's going to be negative. The last set of rules is for multiplying and dividing integers. They have the exact same rules. So if they're the same sign, meaning positive times positive, or positive divided by positive, or negative times negative, or negative divided by negative, our answer is always going to be positive. So it's just a very quick solution. When it comes to different signs, if they have one of each, your answer will always be negative. So if we're looking here, we've got 6 times 7, positive times positive is going to give us positive. We have one of each, so our answer will automatically be negative, and then we just multiply. We have one of each, our answer will be negative, so we multiply. We have one of each, so our answer will be negative, and we multiply. Here we have two negatives, which is going to give us a positive, and we'll get 80. You don't have to put the positive sign, but if you want to, you can for now. When we get into division, I want you to realize that it can come in a couple different forms, and one is using the division symbol, the second one would be using the fraction bar. It just means the same thing, so it doesn't matter either way. So if we have two positives, our answer is going to be positive. 13 goes into 26 2 times. We have one of each, so our answer will be negative. 8 goes into 16 2 times, and we've got a negative. We have one of each, so our answer will be negative, and 4 fits into 20 5 times. The next one, we have one of each, our answer will be negative. 4 fits into 8 twice. The next one, we have both negative, so our answer will be positive, and 5 fits into 10 2 times. The one thing that I want to address quickly before we move on is our rules for multiplying and dividing fractions. If I had 1/2 times 1/2, our rule is going to be this. Multiplying fractions, no big problem, top times top over bottom times bottom. So if I did top times top, I'm going to get 1. If I did bottom times bottom, I'm going to get 4. If I were to bring negatives into this, I could say negative 1/2 times positive 1/2. Same rules apply. Top times top gives me negative 1. Bottom times bottom gives me positive 4. Easy enough. Dividing fractions is a little bit different. It says dividing fractions easy as pie. So we've got, let's just do 1/2 divided by 3/4. Dividing fractions easy as pie. Flip the second and multiply. So I want to flip this second and turn it to multiplication. So it's going to look like this. I kept that first one, flipped the second, now I'm going to multiply. Top times top gives me 4. Bottom times bottom gives me 6, and I can simplify that down to 2/3. If you have any other questions on multiplying and dividing fractions, or adding and subtracting fractions, or any of the integers, please make sure you send me an email. Go through your homework, check your answers, and just make sure that you're ready for class for tomorrow. Here are the rules for the homework. All work must be shown on problems which require more than one step. If you had a problem like this, 3 plus 2, I do not expect you to show me work. If it was negative 3 plus 2, I think that you can do most of these in your head, but when it comes to problems like fractions, where you have to get a common denominator, I need to see your work, because otherwise I can only guess that you are using the answer key to write down your solutions. You and only you are responsible for going through and checking your own work. If there's one that I have a different solution than you, maybe I'm wrong, maybe I've made a mistake, or maybe there's something that you can pick up on your work to see where you went wrong. So you want to make sure that you're asking questions as you need to. And your homework assignments are always due the next day into the happy basket unless I tell you otherwise. So I hope that this first lesson went well, and again, please ask if you have any questions. Have a good day.